In this video, we're going to be creating the design doc for the web app that we're building out. So my goal with the design doc is to translate these system designs and these diagrams into a document and then break it up into tasks that I need to do in order to get to the end product. So you're going to watch me build out the design doc in real time and have a sneak peek into what my thought process are. So in the overview section, I want to have a brief summary of the thing that we're building out, and I'm going to link it to the PRD that I created in a past video. At the end of the design doc, you want to be able to tell a story of how you're going to build out a solution to satisfy these user stories. And you're going to explain that through the system design, the APIs, and the individual milestones and tasks that you need to do. The first diagram that I want to put in is the high-level overview and the 10,000-foot perspective of what we're building out. So I'm going to take this image and then I'm just going to screenshot it and then add it to our design doc. Before we even get to the system design, I do want to mention the technologies that we'll be using. In the previous video, I did go over my tech stack, so I'm just going to screenshot this. So here, now I mentioned that we want to focus on a few different functionalities. We want to focus on user uploads, user downloads, and processing the image. So before we move on, I do want to mention that for our MVP, we're not going to be doing any user logins or user authentication. So what that means is when a user uploads their image, if the user refreshes the page or leaves the website, they won't be able to get their previously uploaded images. The reason for this is I didn't want to set up a database and a backend service just yet, especially for an MVP. The reason I bring this up is because when you do system designs, you also want to design with future requirements in mind. Even though that this is just an MVP and you want to get there as fast as possible, if you make decisions now to get to your MVP faster, but it screws you down later down the road, then it's not going to be a fun time. An example of this during my time at Amazon is, let's say you're storing a user model that stores user information, and then you want to store profile information as well. A profile can mean that you can have a seller profile or you can have a consumer profile as well. One option that you can take is you can store those profile information as separate columns in the user table. But if you do this, that forces you into a one-to-one relationship between the user and the profile. There could be a world where you have one user model and you want to have both a seller profile and a consumer profile as well. By storing the profile information into the users table, you force that into a one-to-one relationship. So an alternative approach could have been, okay, I have a users table, but I also have a profiles table. Now this makes it so that because you have a separate profiles table, your user to profile relationship can be one-to-many instead of one-to-one. So small things like this is something that you want to keep in mind, even if you're just building out an MVP. So here with the user upload workflow, the main thing that I wanted to point out was the fact that we need to generate pre-signed URLs in order to have the browser upload the image onto S3. So here I'm just mentioning that we want to be aware of the use case where if two different users uploads an image with the same file name, we don't want their file names to override each other. So we need to make it so then that we either utilize a unique identifier or append a UID to the file name and use that as the object key. So this is how the workflow is going to go. We're going to want the user to upload the image, and then we're going to generate the new object key name. This is going to be the file name plus a unique identifier or a UID. Then we want to generate the pre-signed URL with this new object key, and then we want to have the browser upload the image onto S3. So now I want to go over how we're going to be implementing the RGB splitting. So I keep mentioning that I want to do visual computing concepts and things like RGB splitting. I kind of realized that not everyone knows exactly what RGB splitting is. So here I wanted to explain what the end process of this Lambda should output. So when it comes to videos and images, it's a bunch of pixels aligned next to each other in like a row by column type of thing. And for each pixel, you give it a color. Any color that you can think of can be created by three different values: a red value, a green value, and a blue value. So here in our top left image, this is the original image. So what I mean by RGB splitting is I want a way to output three different images. I want an image with just the red values, I want an image with just the blue values, and I want an image with the green values. If you were to combine the green, red, and the blue together, it'll create the original image. So here in this section, I want to talk about how we're triggering the Lambda to do the RGB splitting on the image. And we want to take advantage of something called an S3 trigger. And I've been using the word trigger and event source kind of interchangeably, but what I mean by that is there's a thing called an S3 trigger. Whenever you upload an image onto S3, you can make it so that a Lambda will be invoked on that object that you just uploaded. I don't know which object and image that it needs to perform any compute on. In our case, we want to do RGB splitting on it. So here I want to link the article of the S3 trigger. After reading this section and thinking about it a bit, I kind of realized a big issue with this approach. What happens is whenever a user uploads an image, it'll be added onto the S3 bucket. And then we have an S3 trigger that for every object that gets added to S3, we perform RGB splitting on it through the Lambda. But then here in step 3, we want to upload those images back to S3. This is going to be a big problem, I think, because this creates an infinite loop. We take the user image, then we perform RGB splitting on it. But then we put the RGB splitted image back into this bucket, and then that triggers step 2 again, because every time we upload an image onto S3, we want a trigger to happen. So this is going to create a circular dependency. So I think what we need to do is we need a second S3 bucket where the Lambda will output its results into the finished bucket. Good thing I cut this now in the design doc and the planning process. Imagine I was developing and I encountered this bug halfway into my development process. That would have been bad, because if I had that infinite loop, I'm going to raise my S3 bill and I'm going to raise my Lambda bill as well. So here I'm asking ChatGPT for help on this problem that I'm facing with the infinite loop. Here I'm just explaining what my web app is going to be from a technical perspective. Pretty much this whole process here. So then I asked what happens if the Lambda puts the image back into S3, would this lead to an infinite loop? ChatGPT is saying yes, and it's giving me options on what I can do. I didn't realize this, but you can have trigger rules and filters on S3 events. So here you can make it so then that whenever you create that S3 event and that S3 trigger, you only do the trigger if it doesn't have a prefix here. So in our case, we want to make it so then that if it starts with red slash or green slash or blue slash, all the uploaded images, we don't do that Lambda trigger. Another option is to have 2 separate S3 buckets, one for uploads and one for processed images. And another option here is that the Lambda itself can check the object key if it has the /red/blue/green prefix in it. And then I like ChatGPT here because it's giving me pros and cons of each approach. So I have a couple of different options here, and I'm trying to think of which option that I want to go with. I like the idea of event filters because you can have like granular control of what you want to implement. I would say the issue with this is, let's say for example, I accidentally update the Lambda code to say, instead of updating to /red, I update it to /red with 2 Ds. Then in this case, the event filter will say, hey, this is red with 2 Ds. This prefix is fine to process. So then it'll keep processing this image over and over and over. So with event filters, it's very prone to bugs. And then same thing with metadata tagging. If I forget to update the tag, then that's more risk of an infinite for loop. If I add it to my Lambda logic, same thing there. If I have a bug, it's going to have an infinite loop. So I think the most foolproof way to implement this is with separate buckets. That way, even if I have a bug in my Lambda, because I'm outputting the image to a different bucket, I don't run the chance of encountering an infinite for loop. The con with this is I have to create another S3 bucket and I have to manage another piece of infrastructure, but that's a one-time cost. You do that now so that in the future, you can never worry about an infinite for loop. So now that I'm going with the separate bucket approach, I kind of have to update all of my diagrams to reflect this. So let me get into fixing all that. So this is the updated high-level overview of my web app. So the user will continue to upload the image onto their browser. And what's different now is we now have 2 separate S3 buckets. So the user uploads an image to a bucket that will only store user uploads. And this bucket will still have the S3 trigger that will invoke a Lambda to do the RGB splitting. But instead of the Lambda putting the splitted image back into the original S3 bucket, we're creating a separate bucket that will store any processed images. This bucket doesn't have a trigger. Another difference is instead of the website pulling on the uploads bucket, we're not going to pull on the processed bucket. So I'm super glad that I actually caught that bug and that issue. I didn't even plan all of this. This is me actually figuring this out in real life. So this goes to show you the power of taking the time to plan things out now and catching them early in the development process. We're lucky that we're still planning, so we're able to change up our approach very easily. But if we were halfway into developing and we already implemented a bunch of the stuff that we created, it's going to be a lot harder to backtrack all the things that we did. All right, so now we want to go over the user download process. And this is going to be very similar to the user upload. So this part is explaining the naming conventions of how we're storing all the images in our S3 buckets. So the next thing I want to go over is the polling process. So we need to know if the image is still in a processing state or if the processing has finished. When our front end needs to know if the image is done processing, it asks the Next.js application to ask S3 if the /red/object key exists in the processed bucket. So this is making 2 hops, right? It's going from the browser to Next.js to S3. I wonder if instead of asking Next.js to ask S3, could we just pull on S3 directly? I think if the bucket was public, that approach would work. But since the bucket is private, I don't know if my browser can directly query S3 to check if the object key exists or not, right? Because even if it does exist, we still need to ask Next.js to give us a pre-signed URL to get that image. Here I'm asking ChatGPT, I want to implement polling on a private S3 bucket. And I'm kind of asking it, can I even pull on a bucket directly if it's private? Or do I need an endpoint to hit my Next.js application, which will then hit S3 on my behalf? Your React app cannot pull on a private bucket because it requires authentication. So okay, that confirmed my understanding of private S3 buckets. So here it's recommending me to create an endpoint in my Next.js app, which I was planning to do. So I also asked it, how do I even check if an image exists in S3 specifically? Create a Next.js API route, initialize your client, get requests. Man, head object. It needs the head object method. So what the hell is head object method? It retrieves metadata from an object while returning an object itself. This is useful if you're only interested in an object metadata. Oh, okay. So if it returns metadata, that means it exists in S3. So this will be perfect for polling, because when we poll, we don't necessarily want to get the entire object. Maybe we just want to check for the metadata. So this is something that I can include. So I do something like this when it comes to polling. So I have a state in my React code called isProcessing. So isProcessing will default to true, and this will mean that the Lambda is still going off to do the RGB splitting. So if you have this endpoint, it'll hit S3 to check if the image has been uploaded to S3 yet. If it hasn't, then it returns false. If it has, it returns true. Once it returns true, then we set our isProcessing state to false. This means that we can grab the image from S3. So then we have an endpoint here to generate the pre-signed URL in order to download it. So here I have all the APIs I need to implement. And then in this section, I want to go into more details on the API contract that we want to have and expose to our users. So here we have an endpoint for when we want to upload an object to S3. We want to use the put object command. So when we generate the pre-signed URL, you're only able to put an object into S3. It doesn't give you get credentials here. So here, I'm just making sure that when I create the pre-signed URL to put an object into S3, that I can pass it a specific object key. When I mentioned earlier that we want to make sure that if two people upload an image with the same name, that they don't have conflicting object keys. So our solution to this was to make sure that the object key is always going to be unique for each file. We need a way to pass in that specific object key to S3 whenever we generate the pre-signed URL. Usually when I'm doing like a more formal design doc, I'll go into more details and clean all this up. But for this project, I think this is enough information. So I'm just going to leave it at this. So then for the milestones and then the task sections, these are going to be the last things that we need to implement. With these, the goal is to break down everything in our design doc into goals and milestones and individual tasks. If you just take a look at the design doc and all of the system designs that we created and the diagrams, it can get very overwhelming on where to start and how to move on and stuff like that. When you're developing, you want to have a step-by-step guide on the things that you need to implement and like a roadmap. Because the last thing that you want is to be in the middle of developing and not know what to do next. That feeling of confusion and being lost isn't fun. So you want to make sure that you break everything down into milestones. And then from those milestones, you break it up into even smaller subtasks. Take the time now to plan, because future you is going to thank you for being very well organized. So these are the goals and the milestones that I want to hit as I'm building out the web app. The first one being, I want a hello world deployment onto the internet. So with this, I want to set up my Next.js application, my GitHub, and my Vercel to the point where I can do continuous deployments and that I have a shareable link to my own website. This will make it so then that every time I do a git push, I can see those changes on a link that I can actually hit. So the next one being, I want to be able to upload an image. So with this, it'll include the front end of creating components to allow file uploads, and then it'll also include setting up my S3 bucket and all that stuff. And then next, I want to perform the RGB splitting on the image. So this will mean setting up my Lambda and my Python code. Then I want to implement the polling, and then 5, I want the user to be able to download the image as well. All right, so from these milestones, I want to break it down into even smaller and more specific subtasks so that I can achieve these goals of mine. So let me show you what I mean by that. So in order to get to the hello world deployment onto the internet, I need to create my Next.js application, set it up with GitHub and Vercel, and then I need to test that I have a URL that I can hit on the public internet, and I also want to test continuous deployment. This just means that every time I do a git push, Vercel is deploying that new code onto the servers that's hosting my website. And then in order to be able to upload an image, I separate it out into a front-end portion and then a back-end and infra portion. For the front-end aspect of it, I need to set up the UI for it. I need to set up page routing if I need it. And then I also need to create a file uploader component. And then for the backend and infrastructure part, I first need to create an S3 bucket so then that the user can upload their image from their desktop onto S3. But in order to do this, I need to create my AWS account, and then I need to set up the infrastructure as code package so that I can programmatically create this S3 bucket. Then I need to integrate my Next.js application to be able to talk to my S3 bucket and my AWS account. After that, I need to create the API that generates the pre-signed URL to allow users to upload images onto this S3 bucket that I just created. Once that's implemented, I then need to update my file uploader component to call this new API that I created so then that I can upload that user image onto S3 as well. So after we take care of user uploads, I then want to get into the RGB splitting aspect of this. So first I want to create a hello world lambda. I just want to test that when I upload an image onto S3 that I can invoke this hello world lambda that just does nothing. After that, I then want to create the S3 bucket that'll store all the processed images. Here I want to test that my lambda can upload images onto the processed images bucket, because after that all we need to do is implement the RGB splitting, and we've already tested that we've connected all these workflows together. After that, we then need to implement the polling, and that'll consist of creating an API that'll pull on the status of the image processing, and then we also need to create an in-progress indicator while the image is processing. After the image has been done processing, we then need to download the image from S3 and then onto the browser and let the user download that image. So we need to create an API to generate the pre-signed URL to download all those processed images, and then at the end we do want to implement unit tests and end-to-end tests whenever possible. And after all that's complete, we are then done with the MVP of our web app. And with that, we finally finished the design doc for the web app that we're building out. At the beginning of the video, all we started off with was just the system design and all the diagrams, and we created an in-depth document on all the things that we need to implement from a technical perspective. We went into details on all the APIs that we need, and we even caught an issue with our original design that forced us to update all of our diagrams. And then with all these details, we created a roadmap of all the tasks that we need to implement in order to finish out this web app. So throughout the development process, I'm going to refer to this document a lot to know what tasks I need to do and to give myself a refresher of all the design decisions that I made. This web app that I wanted to build out was just an abstract idea in my head, but it's kind of cool to see how I'm able to put all my thoughts into words and writings and diagrams. I have a lot more confidence that I'm able to build out whatever was in my head originally. I've gotten through the hard part of picking all the technologies and coming up with the system design and all the workflows that I need to implement. So all I need to do now is just code it out. We're like 3 to 4 episodes into the series and we haven't touched any code yet. And that goes to show the importance of having a plan and planning things out. We'll get into code in future videos, so make sure you subscribe to stay updated. All right, take care, y'all.